chocolate tea, chocolate drink instead. Okay, so let's look at practice now 12. Right? Before we go into practice now 12, I just want to clarify or let you know about a concept of average weight versus constant weight. Okay? Average. What do you understand about the word average? What did we learn in primary school? What do we do for average? Can you summarize it in your own words? What does average mean? Yes, what is it? Okay, so the critical thing about average, very good. Okay, is that we add them up together, divide by the total number of people, right? Okay, that's what we learned about average. But then later on, when you set 2, you'll learn a different concept of average. Okay? So when it comes to average, okay, weight, okay, it is the same concept. Okay, we are adding up. Okay, summing up the different weights. Okay, and then divide by total number. That is what it means by average weight. Okay, so for example, right, if let's say I have $20 a t-shirt, okay, being sold by maybe shop A, and then another shop sells $15 per t-shirt. Okay, and then finally another one $25, maybe $30 per t-shirt. Okay, then the average itself will be to add them up and then divide by 3 different shops. Right? So that will be the average rate of t-shirts, of cost per t-shirt. Okay? Whereas for constant rate, okay, it is a rate that maintains stable. Okay? It is the same throughout. Okay? That is what the word constant suggests. Okay? So it is a rate that remains stable. Okay? So that we need to be clear about. Okay, especially so when we are going to look at speed for the next section. Okay. Now let's look at practice now 12. Okay. See your topics or if your minute first. In question 1A, it says that a bus company charges $2.70 per kilometer to ferry 36 children for an outing. The company teacher travels for free. Okay, what is the cost per child if the distance traveled for the trip is 32.5 kilometers? So we can find out what is the total cost first. And since we know that it is $2.70 per kilometer, we will take 2.70 times 32.5 in order to achieve 87.75. And then find out the cost per child. That will be 87.75 minus away is divide by 36 children. And that will give us 2.4375. And for money, what is our accuracy that we always want? 2 decimal place, nearest 1 cent. What if the teacher doesn't travel for free? Then how? Why the teacher doesn't travel? What will the cost be? How do we determine the cost? How will change in our working? Instead of 36, it will be 37. Okay, so to take note of what the question actually says, alright, and how it phrases it. Okay, for B part I, it says that a car uses 25 liters of petrol to travel 265 kilometers. Find on average the distance that the car can travel on 58 liters of petrol. Okay, so how do you think we can solve this question? Let's choose one person. Brandon. See who's looking at me. Ryu is Brandon. Okay, so Sifu, okay, tell me how would you go about finding the distance, okay, for 58 liters of petrol? Okay, 265 divided by 25. Then times 58. So will you present your answer in this manner? Or you will calculate first and then update the number times 58. Is it? Okay? Alright. Or the calculation is not wrong, thank you. Can we see it? Okay, well the calculation is not wrong, but the presentation I think we need to improve on it. Okay? So how we could present it. I know that sometimes it can be challenging for us to think about this word statement, right? Okay, in this case, we can work things out proportionally. We know that 25 liters give us 265 kilometers. Taking note that we use an arrow or you can use a long horizontal line. Okay, just do not use equal because they are not equal. Okay, so 25 liters gives us 265 kilometers. We can find 1 liter, which is the objective of doing 265 divided by 25. Okay? You may choose to calculate this value or you can leave it as a fraction as it is. That will be fine as well. Okay? So I didn't calculate. So up to you. Okay? Then after that, 58 liters. 265 over 25, then times 58. Because 1 times 58 will give us 58, likewise this 1 times 58. Okay, and then we will be able to get 614.8 kilometers. Otherwise, if you really want to write statement, what this actually describes is that it is the distance, because 265 is distance. Okay, and this is the liters of petrol. Okay, so in fact it is the amount of distance traveled per liter. Okay. And then in part 2, okay, we want to find out the amount that the car owner has to pay to travel 1,007 kilometers if 1 liter of petrol costs $1.95. Okay, so what would you actually do first? Let's see. Jishin. Your Rose, right? And she's Kyra, right? Oh no, she's Rose and you're Kyra. Sorry. You look at me like you want to kill me. Please don't. Rose, yes. How will you solve this question? 10.6, is it? So 1007 divided by this. Okay. Is it true? Divided by. Hang on, I'm a bit confused. So 1007 divided by 10.6. Okay. Yes. Okay. Oh yeah. 1007 divided by 10.6. Sorry. Okay. So 1007 divided by 10.6. Okay, that will give us the amount of petrol needed. That will be 95 liters. Okay. Questions from class 1? Alright. Then I'll finish it up this. Then the cost.
Cost equals 95 times 1.
Okay, 95 times 1.95. Okay, thank you. Okay, there are few ways that you can do to find out what is the amount of petrol needed. Okay, so for this step over here, okay, alternatively what you could also consider doing, right, is that we know 265 kilometers need 25 liters, so you can do it proportionally as well. Okay, so that will be fine also. Okay, so it's really up to you. What is it that you can understand, what you can calculate. Okay, then after you get 95 liters. Right? Questions? Okay. Yes. Sure. Yeah, the amount of money that the car owner has to pay, which is the cost of. Okay. All right. Let's move on. Okay, let's look at question 2. Okay, question 2 says that in a competition, 5 people can eat 20 steamed buns in 3 minutes 20 seconds. Okay, assuming that everyone eats the steamed buns at the same rate, okay, and that the rate of consumption remains constant throughout the competition, so they eat equally fast, okay. Find the number of steamed buns 10 people can eat in 5 minutes. So there are 3 quantities that we're looking at over here. The number of people, okay, the number of buns, and also the duration. At the end of this question, we are trying to find out, okay, what is the number of steamed buns. Okay, so how do we go about solving this? Because there are 3 quantities over here, we know that, okay, when the number of people increase, the number of buns will increase as well. Okay, likewise the duration will also increase logically. Alright? Okay, so then if we were to have just fixing the time, okay, and looking at 2 things, okay, they will also have different impact. So because there are 3 quantities, okay, let's present our answer in a 3 quantity manner. Okay, somewhat like a table, but you need not draw a table. Okay, so we can find out the number of people, number of buns, and then the time taken. So right at the start, we are given that 5 people, 20 buns, 3 minutes 20 seconds. Okay, for convenience in calculation, let's not have 2 different units for our time. Let's maybe consider having it all in minutes, since we are trying to go towards minutes as well. So 20 seconds is 20 divided by 60 minutes, which simplifies to 3 1/3 minutes. Okay? Right? Our objective is to have 10 people, okay, in 5 minutes. And we want to know how many buns are there. Okay, to work this out, we do this 2 at a time. Okay, we don't be greedy and do everything at one go because it will not work, right? So what we do is that we can consider making this 1 minute first. Okay, because if I have 1 minute, I will be able to find 5 minutes. So if I'm going to change this, I will take either one of these two to change. I cannot change both together, that is the rule. Okay? So let's say I change the number of people, I keep the number of buns constant. So 1 minute, 20 buns. How many people will it take to finish 20 buns in 1 minute? Okay? So you think logically, if I have lesser time and my number of buns remain the same, will I need more people or less people? More people, right? Okay? So therefore, if 3 1/3 to change to 1 minute by proportion, we are dividing by 3 1/3. Okay? Over here, I must also do by proportion. Okay? But because I will want more people, I will multiply by 3 1/3. Okay, in order to increase the number of people. So 5 times 3 1/3. Okay, what will we get? Sorry? 16 and 2/3. Okay. Okay, at this juncture, any questions? Right? Then, okay, because our eventual goal is 5 minutes, okay, I don't have enough space over here, so I need to continue that side up. Okay, so our goal is 10, question mark, 5 minutes. Number of people, number of months, and time taken. Okay, so we are now at 1 minute, 16 and 2/3 and 20. Okay, our goal is to have 5 minutes, right? So let's change this up to 5 minutes first. So let's settle and fix this 5 minutes. Okay, so from 1 minute to 5 minutes, okay, that will actually be a multiplication of 5, right? Okay, so 1 minute times 5 will give us 5 minutes. So that is the change that we are making. Okay, we keep the number of buns the same itself. Okay, then we find the number of people. Now that I have more time, do I need more people or lesser people to finish the number of buns? I just need lesser people, right? Okay, so 16 and 2/3, I will divide by 5. Okay, and that will give us 10/3. Okay, I know that it is not realistic to have 1/3 person, 1/6 person and all that. Okay, but we'll just keep with these numbers first. Okay, so now at this juncture, we have 5 minutes. Okay, and it takes 10 and 1/3, right? 10/3 people, okay, to actually finish up 20 buns. Okay, our goal is to have 10 people. Right? So from 10/3 to 10 itself, okay, I know that I just need to multiply by 3, okay, to achieve a 10. Since I have this remaining the same 5 minutes already, that means that this is the one that will change. So I think about it, okay, now that I have more people, okay, and the same amount of time, will I be able to eat more buns or lesser buns? There will be more buns, right? So I will also multiply by 3. And therefore, 20 times 3, that will be 60 buns. Okay? So at every step itself, okay, we will keep one of them the same number while changing the other two. Okay, so that is the process we go about solving this question. Alright, any questions? Okay, we will do it in this manner whenever we have 3 quantities. Okay. Later on in set 2, we are also going to go into such questions again. Right? That's where we can form algebraic equations, but there's actually not much need for us to do it by algebra. So therefore in set 2, I'll also run it through in this manner as well. Okay. So we always rely on our logical thinking. Okay, whether in reality, okay, with more time for same number of months, should we take less people or more people? Okay. Any questions? Right, let's move on. Okay, there are 4 different types of situations when it comes to rate. Okay, the first one that we're going to look at is simple interest. On Monday, you would have heard our principal talk about compound interest. Compound interest is something you learn in Sec 3. For now, we learn about simple interest. Okay, simple interest relates to money. Okay, if you were to put money in the bank itself, how is it that we earn? Okay, some interest, right? So we will be using this formula, which you need to remember. Okay, what do all these letters represent? I represents the interest earned, or the interest itself. He represents the principal. Okay, not our Mr. Tan principal. Okay, but it's just money, which I'll refer to later on. R is the interest rate. And T is the time. So for example, okay, how much money do you all have now in your savings? Give me an estimate. $20? $100? Okay, as in your savings or in your wallet. As your wallet is where you keep all your savings. Okay, how much savings do you have? Huh? Can someone give me a number? $10? 5. You find like that is what? 60, 80. 88. Oh wow, very hot all the number. Okay, let's do a very hot number. Okay, so that we can all hot. Okay. So let's say, okay, you put $88 in the bank. Okay, so $88 is what we refer to as the principal. Okay, and then in this particular bank, okay, they give you maybe a 1% simple interest. Okay, 1% per annum simple interest. Okay, what per annum means is that per year. Okay, annum means per year. So that means every year, okay, so long as you put the $88 in the bank, they will give you 1% out of the $88. That's what it means. Okay, but of course, for banks, they don't give such high interest. They probably give you like 0.03 or something like that. Okay, so 1% is quite a lot. Okay, then after that, right, let's say you put it inside the bank. Okay, you never touch it, you never add any more money. Okay, you put it in the bank for maybe 4 years. Okay, of secondary school. Okay, right. So this 1% is actually your rate. Okay, and then your 4 years is the time. Okay, we want to know how much interest is earned. Okay, at the end of 4 years. Okay, so this is how we use the formula. Okay, so the formula tells us that the interest amount that we will collect, okay, at the end of 4 years will be taking the principal, which is $88, times the interest rate. Okay, now for the rate itself, R, we only just take the number. I don't need to take the percentage sign. Why is that so? Because actually the percentage sign has already been accounted in the formula of the divide 100. Okay, so I will just times 1, then after that times T, which is 4 years, over 100. Okay, so in this case, understanding about the formula?